It is September 5th, 2013. Nancy Hutchison with LifeRay, and we are in Tualatin, Oregon at Professional Plastics. What we're doing here today is that we're picking up some plastics for the tower that is being built to put the small ray guns, but we're also picking up a very important piece of material that's known as bakelite. Bakelite is going to be used on the giant ray gun as an insulator and also to hold the sphere. So let's take a look. Right now I'm going to walk around and show you our trailer. Right now is full. It is absolutely full. It is full of equipment and materials that we picked up from a public surplus auction that we won in Portland. Now, Tualatin is just south of Portland, and we are lucky enough to be able to make this trip all at the same time. So let's walk over here and let's see. Would you like to see what's happening in the back of this trailer? So this is our last load. This is our fourth load of what we have coming from the public surplus auction. And now let's walk in over and say hello to the folks at Professional Plastics. We're here at Professional Plastics in Tualatin with Jake. We're working on a team, I guess, and getting ready for the radiation.
Let's do it.
Let's do it.
Let's clean the planet up.
Tell me something about Professional Plastics and what you do.
Professional Plastics, as a company, we have about 15, 16 branches worldwide, including one in Singapore. We specialize in all sorts of plastics, but mostly, especially our location, the semiconductor industry. You know, a lot of our products are the higher end stuff that end up in the computer processing plants like Intel and whatnot.
We actually first called you because you advertise bakelite. Now bakelite, why don't you tell us something about what bakelite is? Bakelite
is basically, well, first off, that was the name of the guy who invented it. Since then, it's kind of been bought and sold under different names, but I can't remember the guy's first name, but his last name was Bakelite. It's basically a compressed, almost paper material, if you will. So great for electrical insulating properties like you guys are going to use it for. Man, that's the majority of what people use it for, but it's so versatile. It's easy to cut, it's hard. They even use some of it in the marine industry, if you can believe that. You think kind of paper, that'll just absorb moisture, but they've somehow figured it out where that, you know, that's a great product to use.
Go on eBay and you plug in bakelite, and it's all these different odd objects from like the 1950s and knobs and things like that.
Mm-hmm. Yeah, so that's originally the time period, and when, God, I wish I remembered his name, but Mr. Bakelite, if you will, came up with that material, and I don't remember exactly what he invented it for, but I am pretty sure it had something to do with the electrical properties of it and the insulating.
We're getting a 4x8 sheet from you. It's a 1/4 inch thick. Mm-hmm. And what we're going to be doing is cutting that into two 36-inch circles and then cutting a hole out of that. And that's going to be like the collar that holds on both sides the sphere. Now the sphere is going to be hit with 100,000 volts. What do you think about that?
I would like to see that. Yeah, as far as I know, you should not have a problem with that material. I mean, you guys obviously did your homework, and you're a lot smarter than me on this. So I think that'll be cool, and I really hope it works out, and I get to see something, and we get to clean up the environment together. That's
for the 24-foot giant ray gun that's being built, because we've created a type of shielding here with the smaller ray guns. The smaller ray guns are going into a tower, and we had to have special material there, and we came here as well, and it's 1/4 inch acrylic. And tell us what you've done with the 1/4 inch acrylic for us.
Well, we decided we would donate a couple sheets to you. You know, we had some stock laying around, and we figured, you know what's a couple $100 here to save the planet, you know, if you will. I mean, so we're a pretty charitable company as a whole. So you know, it's been a while since our branch donated something, so I figured now is the time. I asked my boss, and she didn't have a problem with it. So
Great. Well, thank you so much for that. And there's a lot of people that are donating their time too in open sourcing this whole technology. We're going to make sure that you guys get it, everybody gets it out there. So we're going to fire up the ray gun, but at the same time we want the whole world firing this up, and let's just knock it down, folks.
yeah, let's do it. Glad to be a part of it.
Thank you. We are in the warehouse of Professional Plastics. Jake's going to just kind of give us a little look around here.
We have a couple saws here. That one's a big bandsaw. It's made to cut up to 24-inch diameter rod. We have our CNC panel saw over there. It can hold a tolerance from anywhere plus or minus 20 thousandths. So it's probably the best saw in the area. We also have another smaller bar-fed bandsaw down there to cut smaller diameter rods with the precision about the same, plus or minus 20, 30 thou on that stuff. And so as you can see here, those are some of the big rods that we cut into small little pieces for everybody.
Oh, wow.
Yeah.
And these are like your stock here?
Yep, this is just kind of our remnant pieces. So if we have small cuts that we don't want to cut into a full sheet, we come here first.
Great.
We stock all different flavors of material. Acrylics, like you guys are doing.
We have Teflon. We went all out looking for Teflon. We had to take Teflon in 1/8 inch, and then we had to etch it and get it onto plywood because it's so expensive.
Yeah, it is. And we actually get it etched from the manufacturer.
You get it pre-etched?
Yep.
I'm sick.
Yeah, it saves some time because what you have to buy like a gallon of the etching solvent and do all that stuff.
Oh yeah. Okay, so folks, if you guys are going to repeat doing the giant ray gun yourself, you got to come here to get your Teflon.
Absolutely.
And you won't have to go through that mess. I mean, we're showing all the mess, what you had to go through.
Get it ready to bond.
Wonderful.
Under a 1/2 inch. We'll be threading it. Now this might jump a bit. Oh, gotta be careful. Okay.
And so what's the next step?
Tap.
Tap. Tap. So this is basically making threads inside of the hole that you just made.
Yep. So far, so good.
Do you want me to hold the other end here, or do you want this?
Oh, I'm okay. I got balance in the vise.
So why are you making these holes and putting threads inside of them? What's that for?
Oh, to join on another surface.
These are the rods that go out to the emitter, right? And is this where they'll be bolted and attached to the support?
Yeah.
About it, huh?
I think that's one down.
One down, and how many more to go?
I think 3 more.
3 more. What are you doing here?
I'm cutting angled aluminum to a correct length for torque and positioning on the main 4x4 frame that goes under the ray gun.
And what is this piece of equipment here that you're using?
It's a metal cutting bandsaw.
How does it work? What do you do?
Position the piece in the jaws. Line up the blade to the cut point. Tighten the piece in place. Make sure everything is lined up correctly. Engage power and wait for it to finish the cut.
So it just kind of comes down on its own.
Yes, it's auto feed.
Would you like to do that for
Sure.
us here? That's a lot nicer than that's really smooth, than a hacksaw or a reciprocating saw, huh?
Right. Hand-powered hacksaw or a sawzall.
That's,
If this were a round bar, it would be cut a small fraction of an inch longer and then turned down in a lathe to the precise length. But since this is going to be welded, it just needs to be shorter than the maximum length.
Well, these are templates to hold the position in front of the ray gun, and they slide over the quads.
well, this looks like it's a cardboard. What the heck?
Yeah, that's just a mock-up.
It's a mock-up.
Andy will be creating it out of this material here.
Oh, this is the Bakelite that we just got.
The cardboard serves as a mock-up for checking fit before we make the final cut on the Bakelite.
And so the rings around it, we call it the rings of Saturn.
You'll be out of Bakelite for a high voltage insulator because the stainless steel ball will be exposed to high voltage as well as high frequency. So we need insulators, which will be the Bakelite and plastic pipe. This will be riding on solid aluminum bars for main support. The tubes over the rods also allow for positioning for tuning.
John, how do you tune rings of Saturn? I mean, come on, you're tuning a big sphere.
Waveguides.
Distance between waveguides is how you tune.
Kind of like an over-glorified echo box.
An over-glorified echo box.
Yes.
So why do we even have this great big huge stainless steel ball that's being hit with high voltage? What's all that about?
Well, it's the right size for high voltage, like 100,000 volts.
Well, for high voltage, why are we doing the high voltage on here?
Why not?
I think you said something about it. The high voltage actually modifies the RF, forms it, and forms it so that it is carried for a much longer distance.
Yeah, basically. Naval engineering at its best.